Let's look at tables and see if we can identify whether the function in the table is linear, exponential, or quadratic. So say we were given the x values 2 through 6, and the y values that paired with them, that looked like this. Now, if something is linear, that means I add a term every time to get to the next term. Well, to go from 16 to 60, I'm adding something around 50. To go from 64 to 256, I'm adding something a lot bigger than 50. So there isn't that same number being added every time, so this function is not linear. Exponential, on the other hand, you multiply every time to get to the next term. Well, to go from 60 to 64, I times by 4. To go from 64 to 256, I times by 4. So times by 4, times by 4. To go from 256 to 1024, I times by 4. So the same thing happens over and over and over again. If I wanted to put the 7th term, I would take this number, times it by 4. Like I could continue this pattern. Well, there's a way to make equations knowing that it's exponential and knowing that it has this pattern. So first off, there's what's called an explicit equation and what's called a recursive. Recursive, I think, is easier of the two. It just builds on the term before it. Every exponential, you take the number, times it by 4 to get to the next number, times that number by 4 to get to the next number, and so on as you keep going down. So the way we do this, we say the term we're on, f of n stands for the term we're on, was equal to the term before it, so fn minus 1 means the term before it, times 4. So 4 times the term equals the next term. And we would do the same pattern for every exponential recursive function. All exponentials have this piece. This number always comes from what's being multiplied every single time. Now to get explicit is a little harder of the two in this case. The first thing is an explicit takes on a general format like this. B is that times by 4 every time. We at least know this already has 4 to the x because we know 4 is the number being multiplied every time. To find the a, to find the front term, you have to find the x of 0. So in other words, I have x of 2. If I go back 1 to 1, I would do the opposite. So to times by 4 to go down, we divide by 4 to come up. So 16 divided by 4 gives me 4. One more time to get to the 0 slot. 4 divided by 4 gives me 1. So our a is equal to 1. Well, we don't really have to write this here because it's a 1. We could just as well say y equals 4 to the x power. Okay, let's look at our next function. So say we're given -2, -1, 0, 1, 2. And over here we're given 9, 6, 5, 6, 9. Automatically, because it goes down and then up to the exact same numbers, we know it's not linear or exponential because we can't add or times by the same number to get a pattern like this. This has to be quadratic. And this quadratic function is actually x squared plus 5. We know this because this 5 comes from the 0 slot. Now, the last one we're going to look at is if we have the numbers 3 through 7 for our x values, and 8, 2, -4, -10, -16. So notice to go from 8 to 2, we subtract 6. To go from 2 to 4, we subtract 6. To go from -4 to -10, we subtract 6, and so on. So this is a linear function. Well, we have an explicit and a recursive equations we can come up for this. Recursive, just like with exponential, says the term we're on equals the term before it minus 6. So, every single one for linears have these pieces. This number, just like with explicit, comes from that change, that minusing 6 every time. So, the term minus 6 gives me the next term. Minus 6 gives me the next term. That's what that means. Explicit, on the other hand, takes on a form like this, mx plus b. B is the y-intercept, the 0 slot, just like a was the 0 slot in the exponential functions. M is that change. So we automatically know we have minus 6x because the negative 6 is our m. And there should be a 6 here. Okay. Our b, well, just like with exponential, we have to go backwards a couple because we start with 3. We need to start with the 0. So we need 2, 1, and 0. We need to get our way back. So if we minus 6 to go this direction, we add 6 to go backwards. 8 plus 6 is 14, plus 6 is 20, plus 6 is 26. So our 0 line gives us a y of 26. That means b is 26. So we come over here and say plus 26.